My name is Marco. I'm working for Balsamiq. It's a quite small software company based here in Italy and US and Europe in general, but it's small. And the story that I'm telling you today is the completely rewriting of our flagship product. And we start with Balsamiq Mockups 3. That is our product. It is a tool to make wireframes of the UI, websites or UI of applications. And it's quite popular. Maybe you know it. The structure of the app is a typical desktop application. You have views, panes, and with the mouse you do a lot of interaction with the canvas. We display a lot of 2D graphics, and the problem is that it is written in Flash, Air, so it is a platform that obviously is dying, if not already dead. So after 9 years of work on this application, it was time to change, and we are talking about quite a big number of lines of ActionScript code, and application that can run on web browsers as a plugin of platforms like Google Drive, Jira, Confluence, and also as a standalone desktop application on Mac and Windows. And with maybe like 500,000 happy customers who want to continue to have the same application, but with new technology, if they don't care that is made with this or that technology. So when we started to think of the future, it was not so many years ago, because given also the size of our company that is small, as I said, we didn't find easily a framework or a tool to replace Flash, because this app is made also on Flex. It is a framework based on Flash that gives you a lot of UI, a lot of help in designing the UI, in dealing with the file system on both the platform, desktop, Mac and Windows, and a lot of convenient APIs for the web. So browsers were not ready to just write it in plain JavaScript at the time. So we decided to rewrite the whole thing, except that we didn't want to change anything in the user experience. So the application must be the same. The user should not see any change in what we propose. Only the fact that now is new. And the target was to run natively on desktop, Mac and Windows, because we were tired of having a layer between our code and the operating system. Native on mobile, iOS, Android, maybe Windows, because the tablets are everywhere now, and customers are asking for that. And also running in HTML5 in a browser, like a modern web application. Also, since we want to stay small, we don't want to duplicate all the code for each platform. We want to have at least 80% of the code that is written only once. So we are happy to write 20% of the code for each platform. So 80% stay the same, then 20% for Mac, 20% for Windows, 20% for the browser, and still be a small team, or say 4 to 6 developers. We started in 2, then 3, then now we are 4 when we had full power, but maybe 6 one day. So, how do you do a task like this? You have to make some choice from the existing options that we have. Obviously, the language is JavaScript, otherwise jsday. So this is easy. Why JavaScript? Because JavaScript can run everywhere, and everywhere means really everywhere. In the browser is obvious. How can we run JavaScript in a desktop or mobile? We take a JavaScript virtual machine, we put the JavaScript in it with bindings that we make. We can attach it to native code, and maybe it works. It should work. So we started back in 2014, maybe, doing some experiment with SpiderMonkey 1.7. That is the old JSVM of Firefox. It's very simple, no just-in-time compile, no optimization of any kind. So it was very slow, but we knew that it could run really everywhere. And also JavaScript is popular. There is a big community, it's a well-known language with well-known limits, but also well-known powers. And so we were sure that the choice was JavaScript. Obviously, we were kind of scared because we all in the company came from the traditional development of desktop and also mobile, but we never did really JavaScript and web development. So moving to a language that has no static type checking was kind of terrifying. And also we knew that JavaScript is not great when you want to do programming in the large. Programming in the large, I mean a lot of modules and many programmers working on the same code base with a traditional language like C++, Java, or C Sharp. We know that a single developer can manage a lot of line of code. And in JavaScript, we know that it's not so easy. In the company where I started my career, we were dealing with, say, like 2 million of lines of code of plain C, C++, C Sharp, and we could manage all the thing. Now with JavaScript, when you start to go over, say, 100,000 lines of code, is quite a mess. Could be. But JavaScript is the choice. So now we have to find sort of framework or tools to make JavaScript running and build sort of services and framework to make a desktop application like we want. So there are possible choices now that have been developed in these years. One is an approach like React Native. Why not? React Native lets you write only JavaScript. Then it produces native views. You can be quite ignorant of what happens on the native side because it's all done by this very long chain of tools. The problem is that at the time was really young and probably still now doesn't fit our needs. It is a very precise control of what the user does with the mouse, with the keyboard, and performances and 2D graphics and all access to all possible API of the operating system. So I don't think it was the choice. Electron is another option. So you take basically a web view, you wrap inside a container, you ship a web app that looks like a native app. The problem is that we want a true native app, not a web view. It's the entire point of our mission. Because with Electron now it's developing fast, but you will never have the same integration of the old operating system services that you can have if you go native. Or we can try to find a third-party tool like Xamarin, for example. It's just a name. There are other choices. The problem is that is a third-party layer, again, between our code and the operating system or the operating system. And so we don't want to depend, again, we already dependent on Adobe. We don't want to depend, again, on another vendor. And also, what you do with Xamarin doesn't work in the browser yet, as far as I know. So the solution was do it yourself. We did it by ourselves. And it's quite crazy if you think of this this task. But we were skilled enough to program in the native side. So we have only to learn how to build a sort of stable code base in JavaScript. Then we had basically to copy all the features in the old code base and rewrite them from scratch, so not really copy. And it was like a maybe 10-year work, I don't know, no. And we didn't know exactly, we couldn't estimate exactly the time that it would take. So let's look at a bit of the architecture of this monster that we are doing. Don't do it at home. Don't try to do this kind of stuff in your project because we know that it's completely crazy. So this is all the domain of this is the domain of competencies and of areas that we had to work on. So you start with vector graphics, 2D vector graphics. Then you have to deal with the keyboard shortcuts that in the browser are a mess. Then undo redo stuff, the performances, what model view controller pattern we want to use, problems with fonts and text render that must be the same on all the platforms, and testing, assertions, choosing the right way to do real-time collaboration with other users on the same project. So all this stuff that in part was already implemented in the old code base, and in little part we decided to make it better, but still with the same user experience. So the idea is that we have this big core, big in large in size, core of JavaScript code that is shared among all the platforms. And this core is written in pure vanilla JavaScript. So you don't have the DOM, you don't have set timeout, you don't have XML HTTP request, because this kind of stuff is provided by the browser. It's not provided by the language. It's something that maybe you don't realize immediately, but it's just a scripting language, JavaScript. Then we have this native.js layer that we call native.js is an empty interface that abstracts all the implementation of the services, these kind of services that are required to run any application, like dealing with PDF files, with the graphics, with the real-time collaboration, with the SQLite, everything that you can do in plain JavaScript. And then for each platform, for the browser, for the Mac, for Windows, for example, we have this layer, the 20% layer. In the browser will be just JavaScript that calls directly the core. In macOS will be Swift that calls the core code inside a JSVM, and in Windows will be C#, again in another kind of JSVM because we use the Windows one. Over our 20% of native code, we have the library that you can find on that platform. So on the browser we use React for the UI and a lot of other libs. On macOS it will be Cocoa, Windows probably WPF, probably because we didn't start yet Windows. So from another point of view, the same thing is that what do we write in the core, this 80%? A core that is the basic object that holds all the application, the model or our data, the operation to modify the model, the view controllers to deal with the UI, and what we call tasks that is another thing related to the UI. All this stuff that is already in place is this amount of JavaScript line of code is 80,000 80,000 line of code. So it's less than the code that we had in Flash. On the native side, what we hope to be only 20% because it's a challenge. We have the implementation of this empty native JS interface, and we will see better later, a native counterpart for each view controller class that we implemented in the core. We'll see later about this. So native JS is very, very simple, just an empty interface for this kind of services, like I said before. So SQLite, because our file format is based on SQLite. PDF, 2D images, bitmap images, all the thing of the UI, fonts, and precise text measurement, but also asynchronous callbacks that you don't have in plain JavaScript, timers, library to do real-time collaboration with other people working on the same project. Very simple, the SQLite interface has a init to start the library, open that gives you back an ID. They are all asynchronous calls. And with this ID you can do a query, and then you close the database. PDF is like the same. Init the library, you can start a new document, you get back an ID. On this ID you can add pages, send commands to draw stuff, and then save, that is let the user download this file. So the implementation for the web of this native layer is 10,000 line of code, and includes all these libraries plus other stuff: React, SQL.js, PDFKit, PubNub, fonts, Google Fonts, and other little stuff. Then I would like to talk about the UI, the view controllers, because it's a topic that always I'm asked for. So internally, the architecture that we have is this. We start with a model that holds all the data. There's nothing special, just plain classes of JavaScript with data inside. It's very, very simple. We don't have any external library to build the model on. Very simple classes. And the model, through a custom-made event system, even these are very, very simple, updates objects called view models that digest the model data and prepare this model to be read by view controllers. View controllers are responsible of dealing with the views. The views take the input from the user, communicate to the view controller, and the view controller can instantiate operation that modify the model, and again the cycle is complete. Now, every time I explain this thing, some people ask me, and when is saved the data? Where is the storage? Okay, so I added this only for this question that I always. We have an archive. Archive is again an interface that when you are on the desktop is implemented with a SQLite file. If you are on the web, is a connection to a server, to our cloud server. The API is the same, so the application doesn't know exactly where it is saving the data. And so when the model changes, there is a synchronizer that pushes these changes to this archive, to the server or to the local file. And if there is another user connected to the server, another user who is modifying the archive, there is a notification, the archive changes, and the model is updated locally so that all the models are synchronized. If there is a problem, out of sync, missing updates, we can detect that and we simply reload the model. Very simple collaboration. In the very rare case there is a problem. So now the point is, what part of, so let's get rid of the archive. what part of all these, this is basically all the application, is made of subclasses of these base classes. So how can we find the 80% of the code that will be shared, and how can we isolate the 20% of the code that will be rewritten on each application? So all the way left is JavaScript, all the way right is native. So if we put this wall all the way right, it means that we are writing all in JavaScript. So it's like 100% core, 0% native. And this is a solution like Electron, so or WebView basically. That's not what we want. So let's move the wall to the JavaScript side. We can cut the beast here. So we have native view and JavaScript view controller. It is interesting because it's basically what we want, a very thin layer of native code and almost all the rest in JavaScript. The problem is that on different platforms you have a view architectures that are different. So even from the Mac and Windows there are different patterns, different patterns, so it's not easy to write a view controller that can command these two kind of views. And on the web, the view abstraction is even different. If you use React or any other framework, is not possible to do this. You can write a single view controller to command very different kind of views on different platforms. So let's move to the left. Thank you. Again. So let's put the view controller on the native. This works because you have all the UI set on your native side. So this clearly works. You can do what you want on any platform. It is clear what the view model can send to the view controller. It is clear what the view controller can call for the operation. The problem is that this is like 50-50. It's not 80-20. And also, what happens if you decide to change something in a view model? You have to modify the view controllers in all the platforms with a lot of cost. So it's not effective. It's not code reusing like we want. We share too less code. So where do we put this wall? We decided to put it here, in the middle of the view controller. So basically we split each view controller class in two pieces. One, the big one, is JavaScript. So it has to do, it can get the data from the view model, call the operations, is easily updated when something changes in the model or in the view model, or something in the core, in the internal part, can change as you want. And then this view controller produces a little state that is a logical description of the view that must be rendered to the user. And there is a thin piece of code, native code, on the other side that actually deals with the view. Create the view, listen to the input of the view, and what can it do? It calls a predefined set of actions to the view controller. Then the view controller will take the action, perform its stuff, maybe call an operation, maybe update a variable, maybe do something. But this layer that we are putting on the native side is very well defined, very small, and it can have okay, it's very well defined and very small. So, for example, alert view controller. This is a view controller that displays a modal alert with a title, a message, and few optional buttons. This is the core part. So when it starts, it defines this state object, little one. This is what the native part of the view controller will receive. And when the native part of the view controller will detect a click on a button from the user, the action method will be called on the internal view controller. So in this case, just a callback is invoked. And so the question is, all this stuff, did it work? Yes, it is working. And now it works so well that we decided to change the name of the product after we wrote all the code. So now it's called a Balsamiq Wireframe because what we do is wireframes, not mockups in the sense that now is using this word. And so in code we have a lot of mockups, but in the UI is always wireframe. So this is a screenshot of the new product running in the browser. This is all SVG, HTML5, JavaScript, React. There is no Flash, and you can tell anything because it is exactly like before. So if nothing changes, it's good. So about the code is 8,000 on the sharded part, 10,000 for the native, and 15,000 for the view controllers. Is likely more than the 20%, but it is because also on the web there is React that is quite simple as a framework. It doesn't give us many features that we want, like proper handling of keyboard shortcuts, or we had to write more code that what we will do for native platforms. Actually, is a private beta of Balsamiq Cloud. It is our cloud app that we wrote from scratch, but this is another talk, not completely different code base. And instead of having 9 years of experience, now we have at least 99 bugs, but we will be fix them. So this is the entire suggestion for questions and questions that you may have. And if you have questions, I hope you have questions. I can talk for like 6 hours. If you don't have questions, I could already go, but it's your choice now.